Perhaps the most interesting part of ATI's space business to me is that it's really at the heart of exploration. That is something that is very human in nature to want to explore.
Outer space is totally awesome. There's nobody here who works on parts for a rocket and hates it, and that's something where we've had involvement in that as far back as the early manned trips into outer space.
We've participated in everything from stage 1 rockets to stage 3 rockets. We've been a part of satellites. We've been a part of the actual structure of the aircraft. We've been a part of fuselages.
So we cover virtually anything that goes to space. ATI will have some piece of material on that vehicle.
The manufacturing of space products is really unique in a lot of ways. These are events that don't happen with a high degree of frequency. But the products are extremely large, technically complex, and go into some very challenging environments.
A lot of these high-temperature alloys use both niobium and hafnium. And that is a differentiator because there's not a whole lot of companies out there that make hafnium in the first place. I don't think there's anybody else in the world that makes both hafnium and niobium. Because of that, we can control how much we can make for alloys like C103.
A lot of cases, we find that our customers really value the fact that we can source materials within ATI and bring that full solution to them. It takes some of the complexity out of their supply chain, and it actually drives some technical and quality advantages.
The direction that we're really looking at now to improve is looking at alloy systems that were researched maybe even 60 years ago, but they weren't manufacturable.
The alloy development that we're doing in partnership with some of our customers and partners, the ones that have potentially higher strength than C103, but maybe aren't as fabricable.
What we can do now with modern technology like additive manufacturing is produce a powder that's uniform. That's much easier than creating an ingot that's uniform. And we can additively manufacture it directly into a part, and we never have to forge or roll it.
So we're in a new paradigm where if we can get niobium-based alloys in powder form and we can print them, that can get to a part that's never been manufactured before in our lifetime.
When we think about launching people millions of miles into space and the products that are required to do that, it's really astounding what we can accomplish building very difficult, complex parts to support that exploration.
I want to see people on Mars in my lifetime. I want to be part of making the materials that make that happen.
I think as a citizen of the U.S. and certainly a citizen of the world, I think being able to see what comes next is not only exciting for me, but I think it's going to be exciting for the generations to come.